Hello students, it's Julie again. I am here to do one more example of graphing and a linear inequality. Um, this time I'm going to do one that is in standard form rather than slope-intercept form. So again, I will run through kind of what the steps are and why I'm doing them. So follow along. You might also pull out a piece of graph paper and kind of work this yourself as I go through it. See if you can figure out the steps as we go along. And so the last two examples that we did were set up kind of in slope-intercept form, or they were in slope-intercept form. This one now is in standard form, and so now I just need to change my process for how I figure out where the line part of this needs to be. So if you remember graphing in standard form, what I need to do, or one way to do this, is to find the x-intercept and the y-intercept for this line. And so I'm going to make a little input-output table. And what I'm going to do is I am going to figure out if x equals 0, what's y equal to? And then I'll do if y is equal to 0, what is x equal to? And so off to the side here, I'm going to plug in 0 for x. And then I'll have minus 3y is less than or equal to 30. And again, I'm copying down the less than or equal to 30, but I'm really just thinking about this as though it's an equal sign for the moment. 5 times 0 is just 0, so that leaves me with negative 3y is less than or equal to 30. And then I'm going to divide both sides by negative 3. And when I do that, you might remember also that on the left here, this is going to cancel out. I'm going to get y. But when I divide both sides by a negative, I want to flip that inequality sign from less than or equal to greater than or equal to. Do my division here. But in this case, it actually really doesn't, that doesn't affect my outcome too much, because what I'm really just looking for is what is this number here that I get? What is the equal to part for this equation? I want to know that negative 10. So that gives me one intercept. I've got a point at 0, negative 10. So then I'm going to go over here and I'm going to do the same thing, but I'm going to plug 0 in for y. So I'll have 5x minus 3 times 0 is less than or equal to 30. So 3 times 0 is just 0. That leaves me with 5x is less than or equal to 30. I'm going to divide both sides by 5. I'm not going to show that, but I'm going to do it. And then x is going to be less than or equal to 6. Again, I'm not so concerned about the less than part here. What I want to know is that that intercept is at 6, 0. So now I'm going to go over to my graph. I'm going to mark those two intercept points. The first one is at 0, negative 10, so it's way down here at the bottom of the graph. The second one is at 6, 0, so that's over here on the x-axis. And then because this is an inequality, a linear inequality, this is where I have to look at the inequality symbol. And in this case, it is less than or equal to. And so what that tells me is that I am going to connect these 2 points together with a solid line. And I'm going to do my best here to draw a straight line. That's not too bad. Okay, so imagine that that's perfectly straight. But the important part, I've got a solid line here. If I was doing this on paper, I would use a ruler and make it look pretty. So now I know where the line is. I've got a solid line because it's less than or equal to. I want to include all of the points that are on the line in my solution set. And then, so the last thing I need to do is figure out, just like in the other examples when we had slope-intercept form, which side of the line am I going to shade? So again, I'm going to pick a test point, and I'm going to test 0, 0. I can use 0, 0 because this line does not go right through 0, 0. I'm going to plug in 0 for x and 0 for y. And then I'm going to write in the rest of the inequality there. And in this case, 5 times 0 is 0. 3 times 0 is 0. So I get 0 minus 0 is less than or equal to 30. Or in other words, 0 is less than or equal to 30. And that's true. 0 is less than or equal to 30. So that means that 0 is a solution to this inequality. It should be in the shaded section of the graph. So I'm going to shade on the side where 0, 0 is, which means that I'm going to shade up above the line here. Okay. And as we've said a couple of times here now, this doesn't have to be perfect. I want to get as close as I can, but I'm also trying not to go over into the other section of the graph, but then from here I can just kind of fill this in as best as I'm able. So again, if you want to take more time and make this look a little prettier, you're certainly welcome to do that. I could also just use stripes or little bars and make this kind of simple. But here again, just to review the steps, I want to, because this is in standard form, find the x and y intercept, which will tell me roughly where the line should go. Connect those 2 points together using a solid line, because this is a less than or equal to situation. If it was just less than, I would, or just greater than, I would use a dotted line or a dashed line. And then the last step is to pick a test point. 0, 0 works well, but if the line goes right through 0, 0, just pick any other point on the graph. Plug that in for x and y. See if it makes a true statement. If it does, you shade on the side where your test point is. If it doesn't, shade across on the opposite side. All right. So that's my last example. If you have any questions, let me know. Otherwise, happy graphing.